In this video, we're going to try to find un, given that un is a second order recursive sequence. Okay, in our case here, un plus 2 is 2un plus 1 plus 3un, with u0 is 1 and u1 is 2. Here, this is u1. Okay, so the general idea to find in this un is solving the characteristic equation and find a combination of the solutions. Okay, so that's what we're gonna do here. So the characteristic equation in this case is given by rn plus 2 is 2rn plus 1 plus 3rn. Okay, so we can think of un as some r to the power n and plug it here, and we can solve. Now we're gonna solve and find the solutions. Here, minus 2 rn plus 1 minus 3 rn is 0. We assume that r is not 0. Okay, now we can factor out by rn, and we have r squared minus 2r minus 3 is 0. Okay, r is not 0. Therefore, we can solve r squared minus 2r minus 3 is 0. Okay, so this one here, we can solve it in by completing the square, for instance, by adding 1 and subtracting 1, and therefore we have r minus 1 squared minus 2 squared is 0, and this gives us that the solutions are 3. This is the first solution, is 3, and the second solution is minus 1. Now, our sequence will be written in the following manner: alpha r1 to the power n plus beta r2 to the power n. And we can find alpha and beta by using these initial conditions. U sub 0 is 1 and u sub 1 is 2. Okay, so we can write un. Now we know that r1 is 3, so this is alpha 3 to the power n plus beta minus 1 to the power n. Using u sub 0 is 1, we have 1 is alpha 3 to the power 0 plus beta minus 1 to the power 0. So I'm writing this one to make sure that you see where I get this one from. So here I'm going to have alpha plus beta. And when u is 1, when n is 1, we have u1 is 2. That means I have alpha 3 to the power 1 plus beta minus 1 to the power 1. This gives me 3 alpha minus beta. Now I can solve for alpha and beta. So this is a system of two equations with two unknowns, alpha and beta. If I add these two equations, I get 4 alpha is 3. Okay, I get 4 alpha is 3. That means alpha is 3 over 4. And I can use this one here to get beta. Can use beta is 1 minus alpha. Okay, beta is just 1 minus alpha, which is 1 minus 3 over 4, which is 1 over 4. Therefore, I have my values. I can write my sequence, my general term, as I have alpha, which is 3 over 4, and beta is 1 over 4. Therefore, u sub n is alpha is 3 over 4, 3 to the power n, plus 1 over 4 minus 1 to the power n. So this is the sequence solution to this recursive sequence here. Okay, so I can check quick way. So here I have u sub 0 is 1 and u sub 1 is 2. If I plug 0 here, I get 3 over 4, 0 here, 1 over 4. So 3 over 4 plus 1 over 4, that's 1. That's correct. When I have 1, I have 3 over 4 times 1, which is 9 over 4, minus 1 over 4 is 8 over 4, which is 2. And this is u1. So that means when n is 1. This means that my my sequence is given by 3 over 4, 3 to the power n plus 1 over 4 minus 1 to the power n. Okay, so this is the general case when we have so when we have n is when we have the solutions are real. We have different cases when we have the solutions are either real or the solution is repeated. Okay, we will come back to that. Thank you.